Wang. And my talk will focus on embodiment and imagination. This paper with Ying Tung Lin is still work in progress. So we are starving for your feedback, and we will be grateful for any idea or comments in the Q&A section after the talk. So, okay, let's begin. And one popular philosophical discussion is about the nature and location of cognition. There are mainly and roughly two opposing camps in this discussion, namely representationalism and embodied cognition. And one of the main emphases of embodied cognition is on the explanatory role of the body for cognition. And not just the body itself, but also its gesture, movement, and interaction with the physical world. So here we focus on the body's interaction. For an embodied cognitivist, when explaining cognition, one's interaction with the physical world matters. For example, when watching a video on my laptop, my visual perception cannot be explained by only focusing on my current brain processes, but also on how my eye interact with the screen of the laptop. Well, if one's interaction with the physical world matters, the main question of our paper is to ask, how about one's interaction with the simulated world in imagination? Does it matter as well, just like those in the physical world? Our answer is yes. Most of the discussion in embodied cognition only focus on interaction in the physical world and ignore interaction in the simulated world. We suggest taking a step further and argue for the explanatory role of interactions in the simulated world for cognition. So for example, maybe the video on my laptop was boring, so I closed it and started imagining future hiking in the mountain that is scheduled for the next weekend. And imagining the way I take my steps in the mountain will also make an impact on my cognition. Okay, so to capture this main idea, we introduce a concept called simulated embodiment, in contrast to physical embodiment. Physical embodiment refers to the emphasis on the interaction with the physical world when explaining cognition, and simulated embodiment refers to the emphasis on the interaction with the simulated world when explaining cognition. However, one may ask two questions here. First is that in what sense is simulated embodiment a concept of embodiment? And second, why does the interaction with the simulated world matter? Are there any supporting cases? So my mission today is to address these two questions. And so the content is structured as follows. First, we review the concept of embodiment, but we only do it roughly for the sake of our argument. Next, we introduce the idea of simulated embodiment and argue that it can be treated as a kind of embodiment by comparing its underlying processes with those of physical embodiment. In the last section, we show how the empirical studies on imaginary practice may support the idea of simulated embodiment. And specifically, we focus on two studies and discuss their implications on simulated embodiment. So the first one would be about observer perspective imagination. And the second is about the indeterminacy of imagination. So first, a very brief review of embodied cognition. Embodiment is a concept for embodied cognitivists to emphasize the relation between one's body and cognition. And this relation makes the body explanatory for cognition. Well, then what exactly is a relation? The answer differs. Here is a rough yet widely shared distinction of embodiment, the distinction between weak embodiment and strong embodiment. So those who take embodiment to be in a weak sense suggest that mental representations of one's body or movement constitute certain types of cognition, and thus also explain these types of cognition. What is the role of the body? For them, one's bodily interaction with the world shapes these representations about the body. Therefore, the relation between one's body and cognition is a causal one. In summary, bodily interaction shapes mental representations that constitute cognition. As for strong embodiment, it is the body itself and its movements that constitutes cognition, and thus explanatory for cognition. Here is clear that the relationship between one's body and cognition is a constitutive one. Bodily movement and its underlying processes, namely bodily sensorimotor processes, constitute cognition. Well, for strong cognition, what is the role of interaction with the world? Interaction with the world shapes bodily sensorimotor processes, like how it shapes skills, habits, and know-how. So by comparing these two in a rough table, we can see that the main difference between them is in the constitution of cognition and the relation between the body and cognition. Also, there is a difference in how they view cognitive processes. So you can see that on this table. I'm not going through it in detail, but importantly, they share the idea that the past interactions with the world shapes cognitive processes, even though they take the underlying processes of cognition differently. So yeah, for us, we accept the general idea of the embodiment shown here, yet concerning these two senses of embodiment, we are neutral here. For this paper only focuses on proposing the concept of simulated embodiment, which we believe is compatible with both the weak and strong view. Okay, so after reviewing the idea of embodiment, we propose that a further distinction can be made, that is the distinction between physical embodiment and simulated embodiment. So by physical embodiment, we refer to the idea that one's interaction with the physical world matters, in a sense that it shapes one's cognitive processes by its underlying neuron and bodily processes. And by simulated embodiment, we emphasize the causal relation between interaction in imagination and some types of cognition. So next, why is simulated embodiment also regarded as a kind of embodiment? Because the concept of physical embodiment is generally accepted. To answer the question, I will compare physical embodiment and simulated embodiment. That is a comparison between interactions with the physical world and interactions with the simulated world, and see whether interactions with the simulated world also shapes cognition. So for the sake of the comparison, I first introduced the concept of physical embodiment and then compare it to simulated embodiment. Okay, so first let me introduce the idea of physical embodiment. Physical embodiment emphasizes how past interaction with the physical world shapes cognitive processes. The idea is that physical interaction shapes cognition through their underlying perceptual and motoric processes. For weak embodiments, processes of physical interaction shape our brain, and thus the representations of one's body and movements. These representations can partly constitute cognition, so physical interaction can shape cognition. For strong embodiment, processes of physical interaction shape our bodily system, which regulates our movement. This bodily system can constitute cognition, so physical interaction can shape cognition. So for example, let's consider a well-trained athlete who did various kinds of practice about bodily control and rope climbing. And by this past experience of training, the athlete's representations or bodily systems of movement is shaped. When the athlete imagines a scenario of rope climbing, manipulation of these representations or bodily processes of the system that are shaped by physical interaction will be enacted. So in this sense, this is how physical interaction shapes our cognition. As for simulated embodiment, the interaction here are with the simulated world in imagination. And if the underlying processes of these imaginary interactions are also perceptual and motoric processes, then following the same logic of physical embodiment that I had just shown it in the previous slide, we can get a conclusion that also some types of cognition would be shaped by simulated interaction as well. And if the argument is plausible, then simulated embodiment can be regarded as a kind of embodiment. However, should we accept this blue statement? There are empirical supports in cognitive science for the statement. So the first group of empirical supports are that imagination shares some neural substrates with perception and motor control. So for example, maybe supplementary motor areas or parietal areas. Okay, the second group of empirical supports are related to two properties of imaginative processes, namely neural specificity and motor specificity. Neural specificity is the one-to-one relationship between the movement in an imagining and the activated brain area. This means that when I imagine myself doing a specific movement, let's say imagine raising my left hand in a particular way, the related neural processes, so in this case, is the part of the contralateral motor cortex related to my left hand, will be activated simultaneously. But this specificity is not only in the neural sense, but also in the motoric sense. So when I imagine myself doing a specific movement, here also imagine raising my left hand in a particular way, the related motoric process. So in this case, is the contraction of my left hand's muscles would be activated simultaneously. All of the above supports the idea that the underlying processes of imaginary interaction involve perceptual and motoric processes. And the underlying processes of imagining a specific interaction A are closely similar to the underlying processes of acting the same interaction A out physically in reality. Thus, we find the blue statement that we have just shown is plausible. And so simulated embodiment is plausible too. Okay, sorry for that. So supporting cases of simulated embodiment, next I'm going to introduce some of them. And I will focus on two studies on imagery practice here, yeah. Okay, so to argue for the idea of simulated embodiment, we take a look at some empirical studies on the topic of imagery practice. Imagery practice is a method of practicing skills by imagining them without explicitly acting them out. Many studies have shown that mental imagery of a subject practicing a specific skill improves the subject's skilled performance. So it suggests that interaction with the simulated world shapes at least some habitual motoric processes, which is part of the cognitive processes for embodied cognition. So mental imagery here is the interaction with the simulated world and improves, we can change it into shapes. And one's skilled performance will reflect one's bodily sensory motor processes for if you take a strong embodiment stance, and it can also can be representation of one's movement. And if you take a weak embodiment stance, then this would be it. Okay. So, however, we would like to further argue that simulated embodiment may provide something physical embodiment cannot provide or rarely provides. Here we present two cases to support our proposal. The first cases is about observer perspective imagination, or OPI, and case 2 concerns the indeterminacy in imaginative practice. So the first cases is a way of imagination, which is observer perspective imagination, in contrast to field perspective imagination. These two differ in the spatial relation between one's visual perspective and one's body in imagination. So in FPI, one visually experiences the imagined world from an origin within one's body. So the location of one's perspective and body coincide. In contrast, in FPI, one visually experiences the imagined world from an origin outside of one's body, for example, from somewhere behind one's body. So here is a spatial decoupling between one's perspective and body. These two kinds of imagination can be visualized this way. And as you may see, FPI is structurally more similar to the way we visually experience the world through perception. By contrast, an observer perspective is rare in perception. Well, what may OPI provide? Researchers in sports psychology have investigated how the effects may differ when the subjects are trained with field or observer perspective imagery practices. One empirical work studies how perspectives influence tennis skill training. In the study, if one undergoes this FPI training, one imagines practicing tennis skills from within one's own body. In contrast, through OPI, one imagines oneself practicing tennis skills from outside of one's own body. For example, maybe behind the body a few meters away, and one's body may be visualized. The subject are asked to practice two kinds of skills, the closed skills and open skills. The author found some difference in of the patterns of the improvement of these two kinds of skills after the imagery practice through FPI and OPI. And so for closed skills, these skills are the skills that can be unfolded without or only with little consideration of the changes in the spatial environment, like serving in tennis. So when performing a serving, we can perform them by activating the habitual movement. The spatial relation between the tennis ball and body does not matter that much because the height of the ball will be controlled by our habitual throwing of the ball. On the other hand, open skills are the skills that, while performing, one needs to take the dynamic changes in the spatial environment into considerations, like forehand strokes. When performing forehand strokes, the spatial relation between the incoming tennis ball and our body matters because how the ball comes is not determined by ourselves, by our habitual movements or interactions with it. So the result shows that FPI is better at improving closed skills than OPI. And reversely, OPI is better at improving open skills than FPI. Thus, it seems that OPI is better at improving skills that need dynamic or spatial information to perform well. How to explain the results? The results that there is a difference in improvements pattern. So one possible explanation is that OPI is a special case in which one's perspective is decoupled from one's body location. And through OPI, we may shape a low-like relation in a specific way, that is association between the visual image seen from an observer perspective and unfolding or performing the skill. This low-like relation provides spatial information that is not or rarely accessible through physical practice or interactions. So for example, after the OPI practicing when I'm on the tennis court performing a forehand stroke, the underlying processes of my forehand stroke will make the visual image that is seen from the position behind my body emerges and give me more information about the spatial relation between my body and the moving tennis ball, therefore increasing the accuracy of my forehand strokes. So this is the first case. And let's move on to this, the second case, the case 2. This is a raw idea and it would be great to have your feedback on this case too. And also it's a more controversial one. So it's about the indeterminacy in imagery practice. So the concept of imagery indeterminacy is still on debate now. And the answer to it differs. Some take it as a range of variation, and some take it as a neither-nor relation between an object and a property. So here I show one example of it. And some other kinds of view exist too. And the debate around this concept has not been settled down yet. We won't take any specific concepts of indeterminacy here and hope our argument can be compatible with most of them. Imagination offers a simulation that can be less spatially determined than perception and motor control. So the idea is that in perception, the experience is more determinate, and by contrast, in imagination, the experience is less determinate. In perception, a 1 meter tall chair is more likely to be experienced as 1 meter tall. But in imagination, even though we strive to imagine a 1 meter tall chair just like it is, its height in imagination may still be indeterminate. Here is a study that indicates the indeterminacy of imagination and how indeterminacy may impact imaginative practice. In this study, subjects are asked to practice a task, which is throwing a 50-gram ball at the center of a target. The target is 1 meter away from the subject's body. This study measures the improvement of the throwing skill for the task is measured by a pre-test post-test design. The closer to the center of the target a subject's throw is, the better score would be recorded. This measure reflects the accuracy of the throw. The procedure of the experiment is in the order of pre-test, practice section, post-test, and at last transfer test. In the pre-test and post-test, subjects are asked to perform the task physically by acting it out 5 times. In the practice section, the subject would practice the test 20 times. However, some may do physical practice 20 times, and others may do physical practice 10 times plus imagery practice 10 times. In the transfer test, the task has been transferred or varied. The ball is exchanged into a 150-gram ball, and the distance between the subject's body and the targets become 2.5 meters. By transfer test, the experimenter can examine one's ability to generalize the learned skill to other similar tasks that only differ in spatial and force parameters. The result shows that for the performance in transfer test, the combination of 2 kinds of practice is statistically better than physical practice only. This means that by combining physical and imaginative practice, one may learn how to generalize a specific skill into other similar tasks better than physical practice only. One possible explanation is that imagination offers a simulation that can be less spatially determined than perception, and also less determined in required force than motor control. Therefore, imaginative practice or imagery practice allows one to train with an indeterminate distance and required force, which may be beneficial for adapting to spatial and required force changes in the transfer test. So in conclusion, after reviewing embodiment, we introduced the distinction between physical and simulated embodiment, and then we give 2 support cases for simulated embodiment. These cases indicates that simulated embodiment allows us to interact with the simulated world in a way different from the way we interact with the physical world. The first case is an imagination with decoupled first-person perspective or observer perspective information. The second case refers to the indeterminacy of imagination. as a whole, our paper had some implications. So here, we point out that interactions with the simulated world matters and use the studies in sports psychology to support our proposal. And on the other hand, introducing the concepts of simulated embodiment will hopefully draw attention to the special characteristics of interaction in imagination, which may help facilitate development of imagery practice in sports psychology. And that's all. Thanks for the attention.